All right, here we go. We are going to, we're going to learn new strategies today, new techniques, something new. Yesterday, we had just kind of practiced something we learned on Monday. But today, we need to talk about how to do this thing called checking for independence. We've already done that this year. So I'm going to really tie it in to how we did it before and show us that it's really not that different. We're just tweaking it a little bit. Then we have a new strategy of how to organize a data that is just overwhelming with lots of conditional information. All right, so assignment wise, you're going to be doing, it says 33 and 34, but we'll actually do 33 together. So you'll want to do 34 and then 36 and 37. So here we go. Turn on over to page 31 where we're going to start our notes. So on this page, it has an activity where we're supposed to collect a lot of data, and then it just is actually, I think the activity itself is kind of painful and doesn't really actually do a lot of learning. So I'm skipping the activity, but we are going to talk about the two events of being a female and if you prefer English to math. Okay, so we're going to have a little discussion about that. So just in general, though, I want you to think in your brain how you know if the two events are independent. So think in general how you know if two events are independent. Okay, and so somebody's going to tell somebody something. Evens, tell the odds what you think. Go. Said, all right, so let's see what you came up with. All right, so Eva's told the odds, so the odds tell me. Holland, what'd you guys come up with? Okay, and I hope you saw me write that, but that was actually, I don't know if you may or not. So this is the most common response I get. The events don't affect each other. Okay, and I get that. This is the most common thing that I get. And so I need to fix it for you because this is bad. Okay, so we need to tweak it a little bit. I mean, you're on the right thought process, but you're not quite there because our song says independent, independent, independent when the fact that, yes, the fact that you are whatever does not change the probability or the rate of the other thing. Does not change the rate. Does not change the rate of the other event. Okay, so this actually is a very important clarification. Saying the events don't affect each other, that is not really an adequate description of what makes something independent. So now that the evens have had that failure possibly with the odds, let's see if the odds can't fix it and tell me what would it mean if being a female and preferring English to say math, which heaven forbid, but say you prefer English and you are a female, if those two events were independent, what would that mean? Odds tell the evens. Go.
You said odds tell even? I'm bad. I did not mean to step on your toes.
All right, so let's see what the evens say the odds told them. So, Richard, what did the evens tell you? Oh, wait, who told who? Odds told the evens. So, what'd the person tell you? Oh, you were the odd. Sorry, my bad. So, what did he tell you?
It was a little loud, but I think that what he said was is that the fact that
That's a good start. The fact that perfect. The fact that you're a female does not change the rate at which you prefer English. Good. Good job. Okay. Right. So, in fact, I think in our language, it intuitively, hopefully, made sense to you that you were saying, given that you are a female, it is not changing the rate at which you prefer English. Okay. So now, good job. We're going to think back to about the beginning of October when we did two-way tables and we were checking for independence or seeing if there's an association or a relationship between the two variables. We would compare this conditional probability I've written here. This is your conditional. We would compare the conditional probability to the what? Marginal. Very good. So the marginal is that overall. Remember, the marginal came from the totals and such. So here's my next question. So this is going to be for the evens, so get ready. Actually, I'm just going to roll the dice again, so I don't know who it's for. Okay, so get ready. So this second line I wrote here is your conditional probability. Conditional upon you being a female, is it changing the rate at which you prefer English? So my question is, what is the marginal that we are needing to have first? Do I need the marginal overall of female probability or the marginal overall of preferring English? So what overall should be here that we would compare to this conditional? So let's see who gets to tell somebody that. It is evens. So the evens get to tell the odds what should go there. Overall female rate or overall prefer English rate? Go. Yeah, you have a 50-50 chance, but you got to say why. Okay, the evens tell the odds, but now the odds have to tell me. So you might hate that actually, because now you're the one who's going to be exposed. But you can blame the evens if you want. Okay, so back table. They're like, oh, dang it. Okay, so let's see. Evens told the odd, so who's odd back there? Oh, y'all. Why do I always go to y'all when it's the odds? Okay, go. What did y'all come up with? Thought. Which one you think and why? Okay. So they think prefer English, and that is correct. I will tell you that. But now let's see if they know why correctly. So you might be on the right track, or you might be thinking on the right track, but maybe not being able to like exactly know why you think that and express it. And here's what the deal is. Here's why that is correct. I'm just going to do this here. What the deal is this. I want to know if the fact that you're a female is changing the rate at which you prefer English. So how do I know if it's changed the rate? I needed to have known what the overall rate was first. So know the overall rate of preferring English so you can see if then the fact that you're a female has changed that overall rate in which you prefer English. So what I want you to notice is that the overall is the same as what is first in your conditional statement so that you can do the given that behind it, okay? All right, so we're going to now go over to the next page and actually skip the rest of this one. So go on over to page 2, and what you see on page 2 is this picture of some actual data, or some data here. Oh, sorry. Am I saying 2? Sorry, my bad. I meant 32. I'm just a brain dead person maybe by now. So here we go. 32. 32. Going over to 32. And let's look at this table of some values. And think back to when we did a two-way table like this. And we drew arrows. Do you remember when we drew arrows? And y'all are like, I don't know which way to draw the arrows. Okay. You remember having that frustration and not liking it? Okay. Well, so let's see if we can't make it a little better, or maybe you'll get it this time around. So you need to figure out which one of these variables, gender or subject, is the explanatory variable. And that's where your arrows come from. So I want you to think for a minute which one of those is explanatory, and that's where your arrows come from. So talk amongst yourselves, see which way your arrows go. I think, let's say the odds. Odds tell the evens. Which way the arrows go? Did they say something to you? Oh, okay. They did? Okay. You think you got it? Uh-oh. My bad. Okay, sorry. Okay, here we go. We'll talk about it. Okay, so I won't call on you then. How's that? Odds told the evens, so the evens tell me. Evens right here go. Okay. So the gender is the explanatory variable. Okay, good. So then which way should the arrows go? Yep, from the explanatory variable to the total. From the explanatory variable to the total. So there's your arrows. So that's how you would be doing your things, which is actually going to make sense when you do these next 3 problems. Do 7, A, B, and C. And do go ahead and compute the probabilities in decimals. You probably need 3 to 4 decimal places. Okay? Do that real quick. 3 to 4 decimal places. So you see what happens is when you say, given that you're a female, then guess what your denominator is? It is that total females. And given that you are not females, aka male, then it is the total males here. So, I think we're 2 odds tell the evens because I kind of just showed you this. Tell your odds tell the evens if this is independent or not independent and why. Go. Do, 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 do. All right, odds tell the evens. So, Lane, who's even over there? Okay, Miss Hope, go. What's the deal? Independent or not independent? And why is that? the case? That is correct. Because what would have to happen? These conditional probabilities would have to be what? Less than 1% different from the overall marginal. See? Do you see parts B and C? Those are conditional. Conditional upon you being female, conditional upon you being not female. A is the marginal. Okay? All right. So since they are more than 1 percentage point off, that's no bueno. Okay, so you're comparing those conditionals. In fact, I can say that the fact that you're a female does what to the probability of you preferring English? It increases. Yeah. Females like English, prefer English at a greater rate. So now, next, suppose that this table is independent. And this is a really important concept to get. I've seen AP multiple choice questions that followed this line of thinking, okay? So this is kind of some ideas you need to be able to pull from. So what we have here is, let's see, if they were independent, then what is overall happening? I can see overall what is the rate at which you prefer English. Okay, so start with that. If these are, okay, so 55% is the overall rate at which you should prefer English. So now, if the English preference is independent of gender, what does that mean about the proportion of females who should prefer English? It should be 55%. And what proportion of males should prefer English? 55%. So English is preferred by females and males at 55% alike. So I want you to compute that. See, that's your hint, what should be in this table. So we want to do, since we know 55% of the overall prefer English, we want 55% of the females to prefer English. See, so I need to figure out 55% of the 320 females. Yeah. Good. There you go. Once I said that, then you got it and you're running with it. And the same thing for the males. 55% of the males should prefer. So 55% of the females. So of the 320 females, I want 55%. So 55% of the 320 females is what? 176. You multiplied 0.55 times 320. So if they are independent, then you end up with the same rate. And then what about the males? 55% of the males should prefer it. So out of the 280 males, what's 55% of that? 154.55 times the 280. And then from there you can add, subtract, or whatever. What is this here? 144 and 126. Good. Okay. So there you go. So we see that the fact that you were male or female, you were still having the same rate of preferring English. Okay. So in general, how might this look? We're going to skip number 10. But in general, how might this look if I was to write a generic formula? Then I would have my, my marginal. Remember, I have marginal, and then I have my conditional. And so How might that go? Where should the A's and B's be placed for this to determine if items are independent? And then, of course, we're looking to see if those results are the what? Same. So talk amongst yourself. There's 3 blanks here. 2 of them are one letter and 1 of them's the other. See what you think. You could look at one we've done before, like, where's one we did? Where's that? Where's that one? Oh, we haven't done that one yet. I'm sorry, my bad. Sorry. Yeah, actually, you could look at the one that we did there at the. Yeah. You could look at the one that we. There you go. Yeah. Uh huh. Yeah, you didn't write it down. Yeah, you could look at the one that we did first off. Okay. So I'm gonna say given that you're a B. Okay. All right. So given that it's a B, okay, given that it's a B, then we're wondering if it affects the probability of the A happening. And so then if you're a B, is it affecting the probability of A? What do we have to compare that up? What's the marginal we go for? Yeah, we needed to know A overall and then see if B affects A. So that's always the way it's going to be. B. Next, here it is written that way. Okay, so I wrote it and I even put it in words. This means given that B has happened, the probability of A has not changed. Okay, so let's check our understanding. And we're going to do that with this problem that is about the environmental club and snowmobile experience. And so we have this data about not using, renting, or owning a snowmobile, and then if you are in the environmental club or not. So the first question I actually want to ask you is to think about, and then somebody's going to tell somebody something. So the first question I want you to think about is, because I think it's not like way definitive. But I do think there's a better answer. Which do you think is the explanatory variable between these two unknowns? Is it, is environmental club maybe the explanatory, or do you think snowmobile experience is explanatory? So think amongst yourselves, and let's see who the winner is. Ooh, it's evens again. Evens get to tell the odds. That's all good. Evens get to tell the odds which one they think is explanatory and why. Go. It could go either way, but I think I could see one's better than the other. I truly think that there's a lurking variable of like you being a person who cares about the environment. I think that's the lurking variable that we're kind of like not talking about here, but that's okay. We're gonna go with it. So which one do you think? Even stole the odds. So odds tell me what it. Yeah, again, you thought you were off the hook because I called on you earlier today. So what did y'all think? I agree. I mean, I think it could go either way, but I think a better choice is saying the environmental club because, you're environmentally conscious, so you're in the environmental club. And if you're in the environmental club, then that might affect the way in which if you decide to own, never use, or just rent a snowmobile and how active you are or whatever. What do you think might happen? Just if we were to put a hypothesis out there, do you think that if you're environmentally conscious, you would own snowmobiles at a higher rate or lower rate, or do you think it matters? Lower rate, okay, because you think maybe it's affecting, or that they don't want to mess with the environment. It's whatever, gas powered, and it affects things. So let's go check that out. We're going to skip 1 and 2 and go straight for the good stuff with number 3. Number 3 asks, are the events snowmobile owner and environmental club member independent? So my hint to you is you got to use this thing here, and you will have to write that out with the numbers, but I'm not telling you which is A and which is B. You discuss amongst yourself which ones. Remember, the B is the fact that you're a B. Does that change the probability of A? The fact that you're a B, does it change the probability of you being an A? All right, so do that and do the math. I agree. Good. Does the fact that you're a what? Okay, good. So what? So that's your B. Uh-huh. Good. 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 So does the fact that you're a what?
We said this is marginal and then that's
Correct. And this is good. The fact that you're an environmental club, does that change? So the environmental club's your B. Good. And plug in the numbers. Yep. Got to figure it out. Do you see how what's your B?
The B should be environmental.
Good. The B should be your environmental club. FYI, you have to show the notation, and numbers. You cannot just go, oh no, because blah blah blah. I mean, so as you're working, you better be like, what I have over here in blue is not required, but what I'm putting in red is. Could you use a little key thing? I guess, yeah. Yeah. So remember that since we said environmental club is our explanatory, you should anticipate your fractions, going down to these totals down here at the bottom, because so that's probably what's going to happen, because is the fact that you're in environmental club affecting the rate at which you own. So I'm going to be using these numbers here as my numerators because that's the owning part. And my denominators will be is the fact that you're environmental club, that's my conditional, going to change the rate at which you overall own the snowmobile. So let's see how you did. So overall snowmobile ownership is right here. 295 overall out of the 1526. But then, given that you're an environmental club member, what's the probability that you own? So it's 16 over 305. So there's those, of which you get 0.193. So a 19.3% chance overall that you own a snowmobile. But if you're an economic or environmental club member, then it's something like this. So did that kind of follow what we thought might be happening, that the fact that you're an environmental club, you're environmentalists, an environmentalist, care about the environment, you own a snowmobile at a much lower rate? Yes, ma'am. Yes, this is the marginal. So this is the overall. And then see, this one's the conditional, because it's conditional upon B happening. Is it changing the probability of A? Okay. Is that good? Yes. Okay. So now we write out our description. So are they independent? Are owning a snowmobile and environmental club independent? No, so they are not independent. And then you have to explain. And so that explanation says what? The fact that you what? Are in the environmental club makes you what? Or I could say changes the rate or decreases the rate or that kind of stuff. Makes you less likely to own a snowmobile. Any of those things. The fact that you're in the environmental club decreases the probability that you own a snowmobile. Okay? So, I'm telling you that other than this hint over here on the left, there is nothing extra in this write-up. All of that notation and numbers, well, except for this little arrow here. So everything except for that little arrow right there has to be there. Okay? No questions. All right. So, good questions there? All right, let's move on. So that's what your page 34 is going to do for you, is practice with some stuff. And again, talk about independence. So whenever it gets to this independence, you've got to go through this process here. Okay? Anytime it's asking about the independence, you have to go through this process here. Okay. Now, we're going to learn the next thing, because actually, in order to do this page 34, you do kind of actually have to know the next technique as well. So let's go on to the next technique, the next strategy. This one's less involved. Okay? Not quite as big of a deal. So let's see what we got going on here. All right. So what I want to do on this page is give you an example and read it to you and tell, the hope is to teach you what kind of crazy problem this is, and what it sounds like when you read a problem, that you go, ooh, okay, wait, this is way too much. I need to use this strategy. Okay, so we're going to start by reading through this problem. All right, so this says, a computer company makes desktops, laptops, and tablets. And they do that at two different factories. One is in California and one is in Texas. Now, the California factory produces 40% of the company's computers, and the Texas factory makes the rest. So your brain is thinking, how much does Texas make? Of course, we're bigger and better. So now, here's where you should start. Here's where, when you read, it should start getting like a little overwhelming, and you're like, whoa, wait a second, too much is going on here. So listen to what this sounds like. It says, if the computers are made in California, then, and then it starts listing out all these percentages. 25% are desktop, 30% are laptops, and the rest are tablets. However, but if those are made in Texas, so it's another conditional, then 10% are desktops, 20% are laptops, and the rest are tablets. So we were just told if they're made in California, that's a given that they're made in California, and here's all the stuff. Given that they're made in Texas, here's all the percentages. We have two conditional sets of information. That's what makes this strategy necessary. It starts getting overwhelming. If this, then it's these percentages, and if that, then it's these percentages. So that is what we're going to put up here in this big idea. We're going to say if the problem has several what? Good. If it has several conditional probabilities, that gets overwhelming. Then, okay, we're going to finish that out in a second. But I want to actually put here in your notes what that sounds like to have several conditional probabilities. It sounds like this. So I'm even going to put quotes like here I am saying it. If this, then these percentages. But if this, then these percentages, and so on. If this, then these. But if that, then this. But if this, then that. So you're like, oh my God, what the heck? So you'll want to watch the last part of this. So if that is what you hear when you're reading a problem, then your mind should say, I need to organize the data in a tree map. Or I'm sorry, oopsie, my bad. It's not a tree map like our little thinking map things, gosh. It's it's called a tree diagram. Okay. Ugh. Before thinking maps came along, copyright thinking maps, okay? So yeah, a tree diagram. And so I'm going to teach you how to do it. And it's not one of those classifying maps, okay? So here we go. All right, so let's do it. Here's how that looks. We're going to start with our computer company. And we've got all of our computers being made where? In Texas and California. Okay, so there's our first condition. They're either made in California or Texas. And let's put our percentages. 40% were in California, and what was in Texas? Good, 60. Okay. All right. But now here comes some more information. And what is it? If it's made in California, what kinds of things are they making? Yep, they're going to be making desktops and laptops and tablets. And we got those percentages, so let's fill them in. So I got to go back up there and read. Let's see. 25% desktops, 30% laptops, and the rest are tablets. What would that make it? 45. Good. Okay. So that's what's happening over there in California. But meanwhile, back here in Texas, here's what's happening. We're making desktops. We're making laptops. You know what I was just thinking? That on this recording, it's going to, if somebody from like wherever, so from another part of the universe listens to it, they're going to know that I'm in Texas, but like they couldn't hear me and tell that anyway, Okay, but what kind of desktops do we have going on here? So 0.10 and then 20%. So we here in Texas make a whole heck of a lot of tablets. Okay. So I'm just going to kind of draw a little line here, just kind of help separate the stuff. All right. So now we are going to figure out, based on this information, what's happening overall. So overall, what proportion of the entire system is the California desktops? How do you figure that out? Yep, California and desktop is 10%. So 10% of the entire company's things are desktops made in California. And continue. So 12% of the entire company is laptops made in California, and so on. %, and then do Texas. Okay, so I want you to answer the next question that says, find the probability that the computer, or if you pick a random computer from the distribution center out there in Missouri, then, so they all go to Missouri then to be distributed. It's like your Amazon warehouse. What proportion of the entire company is tablets? Yeah, 60%. Okay, so let's talk about that. So the probability, so overall, the company has tablets that are made in California and tablets that are made in Texas. So these are the California tablets and the Texas tablets, and that's 60% tablets overall. All right, read the next one. If we select 4 computers at random from the distribution center, they are replacing them so the probability doesn't change. What is the probability that at least one of the computers is a tablet? And what little phrase just should have popped out in your brain? At least one. Probability of at least one is 1 minus the probability that what? None of the 4 computers are tablets. Okay, and we've already gone over that extensively. So it's 1 minus, that one's not, and that one's not, and that one's not, and that one's not. All right, so what goes in those spots there? Okay. 0.4 times 0.4 times 0.4 times 0.4, and so on. Okay, so ultimately, we have our answer is 97.4%. So if you pick 4 computers, there's a high probability that at least one of them is going to be a tablet. All right, and the last one is a given that. So write out your statistical notation. Given that a tablet is selected. What's the probability? It was made in California. So what's the total probability for tablets? Okay, 60% of the company's computers are tablets. What goes on top? Is it 0.45? Is it whole California go on top? No, because if whole California, if you put 0.45 on top, you know what you put on top? Desktops and laptops and tablets. You only put the California tablets on top. And the California tablets is the 0.18. So if you get a tablet, what's the probability it was made in California? 30%. Good job. There's your assignment. 34, 36, and 37. FYI, 34 uses tree diagrams as well. That almost sounds like my little doorbell that we get back together with, right? Not quite, but similar. Bye.